Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. Hello, everyone. My name is Scott Williams from the podcast team at OMIRCON. This episode offers a follow-up to our recent Energy Talks mini-series about cybersecurity titled Why Should You Talk About Incident Response?, which covers the defensive steps OT teams in power utility organizations can take to protect themselves from cyber attacks. Now, OMIRCON OT security consultant Simon Rommer continues as your host with an engaging discussion with his guest about adopting an offensive cybersecurity strategy to identify and counter cyber threats. So without further delay, I hand over the microphone to Simon. Hi, Simon.
Thank you, Scott. In our previous episode, I spoke with several guests about the steps of the incident response workflow. To have a holistic picture, the next few episodes I'm trying to shed light on the offensive side of security. To start this off, my guest for this episode is Thomas Weber. He is a technical lead for CyberDanube. CyberDanube is a Vienna-based OT security and an embedded security company. He's going to share some stories of his past experience and gives a glimpse of what is going on the other side. Hello, Thomas.
Hello, Simon.
Thanks for talking to me about your experiences. So we talked previously before the recording, and you said that you've been to substations, power plants, and all other kind of plants, and you've dealt with devices that are common in the energy sector. So please, if you could share some stories with us.
We tested a lot of different power plants in the past, wind and water and thermal power plants, oil and gas and stuff like that. And I think it's always really interesting to be a guest in such networks, in such OT networks, and observe how people place devices, so infrastructure devices, PLCs, and really critical devices, which have, let's say, really important functionality in terms of network side. So if it's structured like a Purchase model, so with top-level enterprise network and level 0 device network and sensor network, then you see, okay, there is really, really good security. So it does not depend whether it's a big company, if it's a small company. So it's just the people who designed the network. And if it's, for example, a process control system, so a PCS, which has been built from a third-party vendor like Siemens or ABB, they design really solid networks and really, really solid SCADA networks. So if you have such a vendor in your network, such a process control system, then it's not really dependent whether you're a big company or a small company like Siemens or ABB. You can trust that it's solid, structured, and the security has been tested several times in the past. But if there are older networks or unpatched networks, so it doesn't depend if it's a PCS or a self-built OT network, then there can be a lot of vulnerabilities in the network itself, and you're also finding 0 days. So we very often stumble upon 0-day vulnerabilities in devices, and sometimes even in process control systems that have been tested in the past. And I would say that's one experience that we collected over the few years in the past.
So far, it sounds like basic security assessments. We're both in OT security, but we talked about offensive, and you also mentioned the first keyword, so to say, is a 0-day. Maybe for our listeners, a 0-day is a vulnerability in a device where it has been 0 days since it has been known, or 0 days since the patch has been released, so to say. So this also hints to what you're going to do in such an environment, because, as I said, we're both OT security people, but we have vastly different area of expertise. So what is it that you do in such an environment?
So if we test networks, OT networks, including PCS, the main approach is not really that different to testing IT networks. So information gathering is, I would say, that's just, way to go, how you do it. But you behave different in OT networks than in IT networks, of course. Very often we conduct technical security assessments like the penetration tests in power plants in critical infrastructure. And previously, usually during the kickoff meeting, we always ask for maintenance windows. So if the power plants or the producing process line is in maintenance window due to a scheduled maintenance, or if there is a special maintenance window which will be opened just for us, or one of the product lines or process lines or generators, if it's a power plant, water power plant, let's say, then we ask for maintenance windows if it's possible. And if it's possible, it's really easy, because then you can behave like testing in IT. Not really that in IT security, but kind of in IT security, because you can scan without having fear that you would knock out the whole power plant or the whole process, because then it's a maintenance window. Anyway, then we can test like kind of in IT environments. But if we do not have a chance to get a maintenance window, which is always often the case, then we have to not be really silent, but careful to not knock out any devices where we know that those devices can be fragile during scanning, during testing, and I think that's one really interesting point also for our listeners. There are also networks based on Ethernet technology, which are not really behaving like Ethernet itself. Because if you have a real-time network like Ether, like FlexRay, or like other bus systems, which are, for example, in automotive industry, okay, that's a real-time system. But there can also be real-time systems based on Ethernet in OT. And if you do scans, no matter which kind of scans, over those real-time systems on different devices, you can knock out the whole system, the whole communication, just with the load. So it doesn't matter which ports you are scanning and which devices you are scanning. You just knock out the whole network. And some of you may know CSMA-CD and CSMA-CA, so the collision avoidance and collision detection. And in that case, you will have a problem with all those collisions. No matter if it's detection or avoidance, it slows down. Yeah. And then you have, for example, frequency converters and measurement devices which try to collect those information from the frequency converters, which we had in power plants, in thermal power plants last year. And then it just breaks down, and then you have power loss of the whole power plant, which we had 2 years ago. But it wasn't a big problem because the whole power plant was in maintenance and they just were testing some processes, and we just knocked out one of them, and there wasn't.
So what you're saying is you're going into a substation or into a power plant.
Yeah.
You get permission, of course, first, and then you start scanning like you would do in an IT environment.
Sometimes, like in an IT environment, if we have a maintenance window, if we have no maintenance window, it's usually starting with a ping test. So which devices are reachable? Can I move to the next network segment outside of this network segmentation boundaries, also from different points of the network? So if we can scan or if we can ping devices in level 0, which are on the sensor level, from enterprise level, or if we can just turn it around. So if we can reach enterprise level services from level 0. So such things, also things like testing from one cell to another cell. Sometimes those processes are not set up fully like a virtual model. Sometimes those are just product lines or process lines. Depends if it's manufacturing or if it's a critical infrastructure. And then we test to jump between those processes and things like that. So of course, network segmentation, trust boundaries, and sometimes also things like data diodes, which is often needed for legacy systems if you cannot just drop the support for a generator which costs several million euros. And if it has Windows NT or XP.
Or Windows 7 or Windows 10, which is out of support. Last episode I said it was Q1 2025, but I looked it up. It's Q3, Q4, sometimes in October. It's really good to hear the things that I talked about in the previous episodes, like segmentation and having the right permissions and so on. You guys are really testing for this when they're doing an offensive assessment. And this is also This shows that offensive and defensive side has the same goals, the same viewpoints, and things we do on the defense really make sense or really help against offense. But then you come to the power plant and you scan, you try to get a network map and you get reachable devices. And what comes after that?
So after scanning devices, we look up, it's not a vulnerability scan only, because some of our customers previously asked whether we are also doing pen testing. Of course, yes. So we also say them, yes, it's not a vulnerability scan, because some companies just sell vulnerability scans as penetration tests.
So you have the Nessus report and then you sell it as a vulnerability test.
Yeah, our work is starting with a scan, whether it's Nessus or if it's just Nmap, because we try to not knock out any devices. So for some PLCs, for example, we know we cannot scan them with Nessus or with Nmap and some known parameters like -T4, -T3, depends always how you handle the device. For some devices, we know, okay, there's no problem to scan it with Nessus. Some Siemens PLCs withstand any attacks from Nessus, so also load attacks, and other devices not. But we know them, so we know the differences. And if we scan, or after we scan such devices, we try to reach the services. And then we try, of course, things like web-based attacks. So some of the devices have web interfaces, the OS top 10 things, and command injection and cross-descripting and stuff like that. But we also try to send commands via Modbus, Ethernet IP, and things like that. We also do fast testing on some devices. It always depends if our customers want to set some focus points on different devices in the network or not. So some of them want to test some PLCs in a detailed technical way. And if we stumble upon some weird behavior, which we had in the past for sensors, so for measurement devices, then we have a deeper look on the interface. So it may be some proprietary interface, it may be a web interface, and it may also be just a forgotten configuration of an interface, which we also had in the past very often from the vendor. So the vendor just forgot to deactivate some special features on layer 2, not always on layer 3, layer 4. So it always depends, because they include so much third-party libraries in their products, which is just amazing, because for us it's amazing because we can test a lot of things.
So you already said some very interesting things, for example, that you have to be careful to not disturb the system, which makes you really different from an attacker who wants to disturb the system.
Yeah.
And it also shows that you can easily have an impact on a network without being really sophisticated. We also talked about the Nessus scan, and Nessus is just a program that does scanning, a network scanning automatically. It has different modes where it scans for different things. And if you're not careful, you can overload the PLCs, you can overload the network, and especially some older PLCs just cannot deal with the load of having a lot of requests on the open ports. So this is like the first difference between you guys and an adversary. You take care of the devices and you know your stuff, because you have a lot of experience. For example, you said that you know which devices may or may not shut down, which I would call a denial of service attack, and you don't want to have that. Another difference. And then another thing you said about the web interfaces on the IEDs and PLCs, and we've talked about IT-OT conversions for the last decade almost now, and now we are there where PLC devices have web interfaces, which would have been like sacrilegious a few years ago. And you said a few times already that like in IT, but if you have a web interface, it really is like in IT, right?
And for PLCs and HMIs and all those products which get built and marketed today, it's really often the case that they are using some kind of embedded Linux, a small Linux version, which they often build by themselves, so the vendors, of course. And they always use, or they really often use, I've never seen any different kind of system, they always use real-time kernels, of course, for Linux-based PLC. What else you can use?
Makes sense.
Yeah, makes sense. And some of them also build their own kernels and their own kernel signals. I just say Siemens, for example. Yeah, so vendors are always modifying things on the difference to standard Linux distributions or Linux versions. But it makes sense, of course, because why not including some special GPIOs? Why not including some special real-time processor, which is also the case, for example, for Texas Instruments-based devices, because they have some real-time coprocessor, which is really interesting, but it's also used in PLCs, for example. So this kind of Texas Instruments chips are used in PLCs for exactly this reason. So a real-time processor and can just control inputs and outputs in real time, which is important for PLCs. Yeah. But they have a base system, they have a Linux and a web interface, and you can use USB to update and patch the PLC. You can also use the network interface to upload new versions, of course. But yeah, of course, you have services running on the system, on the Linux, like in IT. So it's really just a microcomputer.
So what you guys are doing is you're scanning first, and then it sounds like you're going really deep into the devices. So in the defensive side, we don't really talk about the devices standalone that much because we have like the bigger picture, and we trust the vendor that they have tested their devices for vulnerabilities and ways to exploit it. But you guys are also doing the exploitation on the device itself.
Yeah, I just have to talk about some embedded security stuff to come to this topic later on. We are also disassembling PLCs and embedded computers, so embedded devices, just to get access to the operating system level, because a router, an industrial router or a PLC does not have a screen or a keyboard or no mouse and sometimes no interface to plug in a USB stick. So we have to screw up the device and to look at the PCP. I mean, just as a disclaimer, this kind of security testing or penetration testing assessment is sometimes an engagement from a vendor, sometimes from a bigger company which is using this in critical infrastructure or some kind of other customers, but often those two types of customers. And they just give us the device, having an engagement and say, please do a deeper security test on this level of technical perspective. And yeah, then we just disassembling the device. And we try to get access on system level, operating system level, for example, via UART, which is the universal communication channel. So it's just a serial interface. It's more a testing interface. I would call it like a testing interface because debugging interface is often the JTAG or the SWD interface for ARM chips, for example. But of course, yeah, you can also see this debugging interface. So you can interact like with a standard Linux really often, because as a lot of devices have a standard Linux on the system, you can just try to log in. For some devices, you just get a root shell immediately without login. But nobody, and also not really the developers of those devices, are thinking about that someone opens the device and tries to get access to the UART interface, because who would do it? But we are doing it.
In critical infrastructure, that's a case that we have to think about, because the substations are quite far distributed. I mean, Austria is quite a small country, but if you think about Finland or Norway, for example, they have like a really big gap between the substations. And with the substations, not every time there is somebody there. So you can break in and then do your thing, upload new programs, upload new processes. And this is a threat model that has to be considered.
Yeah, it's the physical layer. So it's really get your hands on the device and modify it in any kind of way. And this one is, in my opinion, it's also really a problem for those kind of distributed substations where you have PLCs which may not really are locked in a big cabinet or things like that. And for some vendors, you can open the PLC without unscrew any screws. You can just open it without screwing anything, which is a good thing because the housing of the whole PLC is really modular and you can really reuse the design for building bigger PLCs, smaller PLCs, and you do not have to throw away the whole PLC if you just break the housing a little bit. it's really nice. But at the same time, it can be a real problem because you can just open it. And if you know where the debugger is, where the debug interface, the UART, whatever is, you can access the device. And also without having any traces on the PCP, you can also sometimes it's just really invisible or silent. And then you can modify the device and modify some processes which are running on the device. And they are, of course, really critical. So if it's a substation, then you can just cause a power outage in a whole city.
And you can cause it repeatedly because nobody would know that you tampered with one specific PLC.
Yeah.
But this is quite low level already. So it does more matter for, as you said, companies like Siemens, ABB, Schneider, and so on.
It's also interesting for customers because from another point of view, not really attacking devices on this level, but doing analysis of the whole device from this level. Because if you are scanning from the network side, which we also really often do, you don't really know your device. You just know which interfaces are accessible via the network interface, but you don't really know which processes are running on the device, so which services are running. You just know them from network side, but you don't know the insights on operating system level. And for that operating system level insights, UART really helps you because you can get access, for example, with root permissions on the device or with user permissions, or you have to unsolder the memory chip and do a brute force on the password hashes, and then you get access. It's also possible. We also did it in the past. It works, but it's cumbersome, of course. But at the end, you get access to the hardware and you can interact with the system. You can pull out the whole firmware. And if you have access to the firmware, it's no matter whether it's compiled or whether it's a script for the web interface or for any proprietary protocols, you can do analysis like gray box analysis, white box analysis, and you can observe the operating system and the services, how they behave if you send inputs from network side to the device. And then you find vulnerabilities like 0 days really efficiently. And that's also a thing that we do during security assessments. So if we have time for that, we pull out, for example, the firmware from a device if we get a spare device, because a lot of companies in critical infrastructure have spare devices for just for use or for testing or for whatever, if they need it, if some device breaks during operation, of course. And sometimes we can test those spare devices. And sometimes we get extra devices just for only testing them and identifying security vulnerabilities in them. And this is, I would say, a real difference to usual security assessments or penetration tests, also from IT's perspective. For IT's perspective, you sometimes get a client. You get a client, a Windows client. You can do security testing on the host itself. You can observe your processes and stuff like that. But that's not possible for embedded devices. You cannot do it. And for that, we have to look behind the scenes and try to get our operating system level access. Sometimes it's not possible because sometimes UART is, for example, deactivated. And
which is a good thing.
Which is a good thing, of course. Okay. And I mean, we can also try to get access to the bootloader, which is also sometimes accessible via this way with a different frequency. So baud rate, so you can sometimes have different frequencies for accessing the serial interface. That's also a thing. But you can also try to break the bootloader and get access to the device from hardware level side to the operating system. But sometimes also this way is not possible because it's deactivated in the kernel. Yeah. And then we have, so that's our solution, we have the possibility to emulate the firmware. I mean, it's written on the roll-up here. It's a bit advertisement, but it's a niche product anyway. And we try to start up the operating system and all the services which are running on the firmware with emulation and test it via this way. Would be the same way like getting UART access and root access to the device, to the physical device. But in this case, it's with Medusa, it's just emulated and you have additional tools, additional debuggers, which you usually do not have on the real device because the developers do not care about having a GDB server on the production PLC. Why should they have it?
So what you say is that even though you go quite deep into the hardware, this is also a benefit for the asset owners because they know what their devices are capable of and they know how secure their devices compared to what the vendor is claiming how secure the device is. And this is another step that we as defenders, we do vulnerability management, but we are dependent on guys like you to find the vulnerabilities in the first place. But let's get back to the whole approach. So you scan, you look at the devices, you said you show that there is connections from the different Purdue levels, which breaks the Purdue level, which shouldn't be. But you also said that you have to touch the physical devices. So for you guys, you're allowed to go in, but are you also doing some kind of people testing or like breaking into stuff?
So red teaming, so it would be an OT red team. It's not really our focus. We assisted in red teamings together with other companies, but usually we just do the technical stuff and searching for security vulnerabilities and for network level vulnerabilities. But red teaming in combination with other companies, yes, but then they also have the red team lead. So we are just doing some tasks and do supporting and sometimes searching new vulnerabilities for assisting the red team. So that's also sometimes our part. But usually the red team lead is lying on the other companies' focus on.
So this shows also specifications and specialities inside the red teaming side or inside the penetration testing side. Next episode, we're going to talk about somebody who does exactly this. So you guys more the technical side, the hackers, so to say. So I would say that you are the typical hacker. So I've known you as a hacker. That's why I invited you. But there is also guys and girls that test people. You're testing technology. But the weakest link in this whole chain is most of the times the people, the engineers. And that's why it's also important to have some kind of awareness against this and have a awareness on how my system behaves, because if you change something in the system, the engineers in the fields, the first ones that should notice. But I teased some stories that you brought. You said in the beginning that you turned off the power once. So maybe you can elaborate on that, how you did it, what happened?
Yeah, so we tested a thermal power plant where a few things were in focus of the technical security assessment. So the surveillance system, all the cameras which are placed around the power plant itself, also observing the thermal process, so the oven. And it was quite fun just scanning the network, seeing that some of the cameras were open, so no password was set, and then looking at the picture from the camera, and it was just an oven burning, like you're looking into a crematoria. Was a bit weird, but yeah.
The thermal power plant after all.
It was the thermal power plant, so that the heart of the power plant itself. And we also tested a lot of PLCs inside the power plant, and where we knew, okay, those PLCs shouldn't be touched too much, or with care, we don't send too much network traffic to the PLCs, because they were older models. So the power plant was built around 2005, 2004. So they used PLCs, well-known PLCs from 5 years ago. So to be sure that they will work, which is okay, and which is also way to go in operational technology, of course. And but that was not really the problem. The problem was when we went into the more technical processes. I mentioned the frequency converters, and they needed frequency converters for generating power, or for ensuring to have the right frequency sent out to the rest of the power grid. And we scanned a bit too much aggressively on the web servers in this network, which is usually not really a problem, because it was just a web server. It was not really active, so you just were able to see information, to gather information, but not really to do any actions like turning off the device. But we sent it too aggressively, and I told you before, some networks which have Ethernet plugs are not really designed to be used as a traditional Ethernet network if you have some real-time communication over it. That was the case. And we sent a lot of scan requests to the web server because it was a self-built web server, and you never know if they behave like Apache or Nginx, because they always depend differently. So you have a lot of attacks where you think, okay, wouldn't be possible today anymore because it was in 1995 when this attack was a problem. But self-built web servers on embedded devices. And so it's really funny. And it's like a gold digger mood in this kind of scene. So in the embedded and IoT scene, because self-built services are always interesting and always fun. Anyway, we scanned it, and then the frequency converter, which we didn't touch, just break down. It was just red blinking lights. So also the lights in the maintenance room were just wending off, and so the emergency light was lighting up, and that's it. And after that, we hear just some noise in the background. So a few people talking about what was happened, and I was just wending out of the room and was saying, okay, I think that was me. And my colleague was sitting in the office room because we were testing from different points of the network on different devices, of course. And he was hiding under the table because he was thinking that anyone will come to the office room and will be really angry. But it wasn't a problem because it was in the maintenance window and it was okay. But
that's why it's really important to know what kind of devices you have and also the interoperabilities.
So in the moment of happening, it was shocking a bit, but that's part of such assessments. We had also another interesting story last year in summer, I think, on another power plant where we find a PC from a non-employee or an external provider who was doing maintenance on some devices. We were not really aware that this host was not supposed to be in the network every time. My colleague was just stumbling upon a host which was suspicious. And let's call him John, the external employee, the external provider. He was just stumbling upon the host of John. And my colleague were curious, like we all, during the security assessment and found some open ports. And one of the open ports was SQL, I think a SQL login. So he was able to log in. He used default credentials, which are set on some SQL servers, and were logged in. And then he found a lot of information also about other companies, because the external contractor, the external provider, was also doing maintenance for other companies. And then he told me, that's weird. The company which is having the production plant next to this plant is also in this database, which is a bit, why? And after talking to our contacts from the customer side, it turned out that John was the same day as we were doing the security assessment in the power plant. It was a Tuesday, and we were the whole week in the power plant, and John was in the power plant on Tuesday, where we did the first scans. And it was a bit strange because he were just opening the whole customer database of John. And he then saw, okay, it's not a good idea to have a default password on the SQL login, which is exposed to the network side. So from our perspective, it was part of the permission to attack because it was a host in the network, but it was a bit weird to just realize that you are on a PC of an engineer who is doing maintenance on different companies which are in the same city. And
so basically he got the free pen test for being at the wrong time at the wrong place and having default credentials.
I would say it was the right time and the right place, because after that it never happened again, as far as I know. So John is now really secured on his notebook and also his SQL database. I hope so.
But this is a really good example of the value for a customer when you do a penetration test, because you test things that normally you would not think about. Because this notebook could be with your data in somebody else's network or something like this. And also this notebook is an external notebook and it could bring some malware into the network. I mean, that's how Stuxnet was distributed back in 2015 or so, 14, 15. Correct me if I'm wrong.
I think 14.
So they distributed it via USB sticks and infected the USB sticks. And this shows the value. It's like not only the embedded device testing, but also like the general functionality test of a network and also the general security posture. because the embedded device testing sounds really fancy. It's more like a really deep testing. And as far as I know, it's not always part of a pen test because it's really time intensive and really expensive. But the network scanning and like all the general security stuff is the main benefit. So what did you do afterwards? You just wrote a report. So there's an external service contractor.
Yeah, so we also try to write the report in the manner how our customers get the most benefit out of it. So in some cases, the power plants are maintained by different companies. So some power plants have different service contractors are responsible for different kind of the power plants, or the thermal power plants for some kind of preparation of the material which gets burned, and other contractors for the oven and things like that. And for such a customer, we write usually chapters just for each contractor so that they can also snip out this part of the report and send it to the contractor. So which is the way to go because it's really easy. And the contractor can patch the vulnerabilities or whatever he has to do to fix it. We also give our recommendations for each vulnerability. So for each technical vulnerability, like network segmentation, do network segmentation, segment it in those VLANs and things like that, or outdated software or some 0 days, send it to the vendor of the device and activate encryption and all the stuff which you can imagine, which you can find in the network and which are vulnerabilities, of course. And what we also do is to have a short call, a short update for the vendors and also for the customer. So if they want it, they also can include the vendors, which is sometimes the case, that they include the vendors and the service contractors, that they know and that they can ask some questions how they can resolve the vulnerabilities. And that's also really, I would say, a core part of the penetration test, like the report itself, because it's the value for the customer or for the vendor. It's the main value because they just see the report. Sometimes they see things like John popping out in the network, and that's really interesting. And it's also really funny for the customer itself. But the most value is the report, and sometimes the call at the end of the penetration test or the debrief, if you want to call it like that. And it's, I would say, in 90% of our penetration tests or of our technical security assessments, the customers wants to have a call like this, where they get a presentation of the report, where they get a presentation of the whole management summary, of the vulnerabilities, and also if they want to have the technical presentation of each vulnerability, how to resolve it and why it's a problem. And we also have risk ratings of severity and likelihood. So to rate it in, like in a risk matrix. And
so what you say is that the penetration test can also help with supply chain management and supplier management. And the report is the thing that you get paid to do, basically, because it's the main benefit for the customer. And the customer needs to have something that they can act upon. And that's why the briefing or debrief is really important and makes sense to get the vendors on board.
Yeah. Sometimes we also include a checklist for those vulnerabilities that we have identified during the penetration test, so that the customer can just check which tasks he completed. And so it's, for us, it's easy to do because we just have to collect the vulnerabilities and add the risk, and that's it. And add another field for the customer to check it.
Yeah.
Of course. But so that's really nice also for the customer, and it's not really much work for us.
And your customer is not always management. So that with the report, with the checklist, they can go to management and see, okay, the money that we spend on the penetration test, this is the outcome, because it's a transaction money against the report, basically. And with the report, management can say, okay, we've become this more secure, or we have identified these vulnerabilities in our systems, which is also good for the shareholders again. Sometimes the shareholder is the country, sometimes it's privatized, but you have to do security nowadays, which is not non-negotiable.
We also do another thing after presenting the report, after sending the report to the customer. We are also listed as CNA, so we also publish CV numbers. I mean, also as researcher, and we also assist in publishing CV numbers for other researchers, for partners from us. And we also write advisories for devices and send it to the vendor. It's not always the case that in each engagement we find a zero-day vulnerability. It's not always the case, of course. But when we find it, we offer it to our customer to do the whole disclosure process, because we have a disclosure process as a CNA, and that we also handle the whole communication with the vendor. So the customer does not pay for it. So that's just a pro bono service that we offer, but it's also not mandatory. So if the customer says he do not want to send the vulnerability to the vendor for any reason, you never know, then we just let it in the report and send it to the customer, and that's it. But we always offer it, and you can see it on our website. We have published some vulnerabilities in the past, in the last 3 years. And yeah, on OT devices, on routers, on different devices.
So you're making the whole industry more secure, pen test by pen test.
We try to do it. We try to do it. So some of the vendors are really glad about it, and other vendors are just, I mean, I don't have to tell you, like they sense their lawyer. That's, yeah.
I mean, for us as OMIRCON, we also do vulnerability management with our station guard solution, and the quality of the advisories shows how important this topic is for the vendor. So for some vendors, we write the advisories ourselves and give it to the vendor because they can't be bothered to do it. And for others, like Siemens or like the big ones, they are quite good with the advisories, I would say. There's room for improvement, but it's gotten better in recent years. So this shows really the importance of doing pen tests. If you want to take your security seriously, sooner or later you have to do it. It's also in some legislature. So for the NIS,
yeah, NIS 2 and Cyber Resilience Act, of course.
Yes, in the Cyber Resilience Act, it's stated that you have to do external testing, which is basically penetration test. And I hope we showed how important or how valuable it is. Thanks, Thomas, for talking to me and then sharing your experience.
Thanks for having me in this podcast.
And with that, I give back to Scott.
Thank you very much, Simon, for hosting this episode, and also for your discussion with Thomas Weber about adopting an offensive cybersecurity strategy to identify and counter cyber threats and power utility organizations. We really look forward to your next episodes and discussions with your guests about this topic. And to our audience, a big thank you for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. OMIRCON has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, please visit our website at omicronenergy.com. Please be sure to join us for the next episode of Energy Talks. Goodbye for now, everyone.